continue to part 2 on the topic of capacitance. Okay, so today we are going to learn about how to find a current, voltage, power, and also to calculate the series and parallel of the capacitance. Okay, so first we will look at the current. Okay, the first point is we look at the current. Okay, and we have learned before that charge Q equal to CV, which I is the current equal to flow of charge over the current. So you can replace it dq over dt. Okay, we will using these two equations, and C is a fixed value, so it will maintain as C, and V also change with the change of I, so it will be dV over dt. Okay, so to find I will be dq over dt, so I equals C multiplied by dV over dt. Okay, and then once you have calculated for the current, you can calculate for the voltage. Okay, and it's an inverse of the current, so it will be then it will be dV over dt is C here we bring to the other side will be 1 over C multiplied by I, and then we want to left the term V only, so the derivative here, differentiate here, we will move to the others, so it will become integrations. Okay, so V equal to 1 over C integral between 0 to t I dt plus with the V naught. Okay, V naught here is mean the initial voltage inside the capacitor. As we know that voltage capacitance is a component that store the charge, right? And it's stored in term of voltage. Okay, so when we calculate voltage at time, we need also to consider with the previous value or initial value of the voltage inside the capacitor. Okay, next is the power. Okay, so we have learned 2 items. The third one is the power. Power, as we know, is VI, voltage multiplied by the currents. Okay, and we know that I is C dV over dt, so you can just make it like this. For instantaneous, it means that P depends on time will be equal Vt It, and It you can replace it with C dV over dt. Okay, so that's the power calculations. Okay, and the next is series and parallel. Okay, series and parallel of the capacitance. Okay, we have a series capacitance for us. The capacitance is inverse tie from the resistor. Okay, so for a series you need to do 1 over. Okay, so total capacitance, let's say you have this circuit. Okay, the red one circuit here, so the C total or the total capacitance will be 1 over C1 plus 1 over C2 plus, okay, so if you follow the circuit, it will be plus 1 over C3 and plus 1 over C4 and inverse. Okay, remember to use, okay, here remember to use the key of x minus 1 in your calculator. Okay, so x minus 1 is mean 1 over. Okay, and then for a parallel circuit, it will be like a series in resistor, so you just need to total up all. Okay, let's say you have 3 capacitance in parallel. So to find the C total will be C1 plus C2 plus C3.